Okay, now we're going to study something that we've talked about in the past. And this is that 17-letter word, electronegativity. So, to remember, we thought of electronegativity basically as strength. How strongly does that atom, or an atom of that element, pull on valence electrons? So, if we look at hydrogen chloride, and we look at the electronegativity of Cl, it's about 3.5, and H is 2.1. Those numbers are on your periodic table, so you don't need to guess. I mean, it's nice to know the general patterns, but you can look at the numbers. So what we're saying is Cl is stronger than H. But they're in a covalent bond here. The H and the Cl are sharing 2 electrons. That's what's making them stick together. Both of those nuclei are attracted to the shared electrons. But in a covalent bond, the shared electrons move closer to the more electronegative atom. So Cl is stronger than H. They're fighting over those electrons. Neither is willing to let go, but Cl is stronger, so it's pulling the electrons more closely to its nucleus. So instead of those electrons being there, they're going to shift a little bit closer to Cl. So there's more time that the electrons spend closer to Cl, so Cl gets partially negative. Now the electrons are further away from the H, so that means that it is partially positive. And here's the official definition of electronegativity. The tendency of an atom to attract the electrons that are involved in bonding. The last note from this slide, you'll notice that we can draw an arrow. This is called a dipole arrow. And we note that we go from plus to negative. So the plus side gets like the little plus, and the arrow points to the negative side. Okay, so a dipole. This is a polar molecule or a polar bond between atoms. You don't need to write this whole part about a crossed arrow is used to show the direction of the dipole, and cross arrow, blah, blah, blah. This is a little bit too much. Just note that the arrow points from partially plus to partially minus. That's all you need to note here. So when we're actually going to be looking at these molecules as we move forward, you're going to be drawing these arrows in, and you're going to have to figure out which side is partially positive and which side is partially negative. So bonds that we're just going back to what we've learned way back in the year. So this stuff keeps coming up. So we're not going to talk about metallic, but bonds that involve sharing or transferring electrons fall into 3 categories. We're going to leave out metallic. So we have ionic, then we're going to have polar, covalent, and then non-polar covalent. Now, in ionic, the difference in electronegativity is so large, that so I'm gonna use that other delta electronegativity, so large that electrons are transferred. So this happens between a metal and a nonmetal. Now, in polar covalent, they have an unequal electronegativity, but are still sharing electrons, just not in the middle. That's a terrible way of saying it. Not in the middle, or not evenly. So here you're going to get partial positive and partial negative. With ionic, you have full plus and full negative. Nonpolar covalent, these is with equal electronegativity, and electrons are equally shared. The bonding electrons are equally shared. Okay. Sorry, I'm looking through my notes a little bit. Okay. So these are three types of bonds. And now, wrapping up, what makes a molecule polar? So we've started looking at larger molecules, not just individual bonds, but so what makes a molecule polar? So polarity in a molecule is caused by unequal sharing of electrons between atoms. And we've already seen that electronegativity is just how tightly they pull on their shared electrons, how much they want the valence electrons. So anytime two atoms with different electronegativity values share electrons, so share electrons, this means what kind of bond? That's right, covalent. There will be partial negative charge on one atom and a partial positive on the other. And their bonds can be classified as nonpolar covalent, polar covalent, and ionic, as the difference between the electronegativity between the two atoms in the bond increase. So with nonpolar covalent, there's no difference in electronegativity. Or very small, I shouldn't say no, very small difference in electronegativity. Polar covalent, nonmetals with a larger difference in electronegativity. And ionic is metal and nonmetal, and they have large differences in electronegativity. So electronegativity can really help you understand how atoms are going to come together to form a bond.